Okay, that brings us to Newton's first law. Okay, so we have three different laws that Newton's generated that help us talk about motion and why things move the way they do. The first law talks about inertia. Okay, so a new term for us, inertia. Let's take a look at his law first. So Newton's law says an object at rest will stay at rest, or an object in motion will stay in motion in a straight line until acted on by a net force. Okay, so before this law came out, the general principle was, the general idea was that there was some sort of force always acting on things to keep them moving. Okay, so by Newton saying, hey, no, if it's not moving, there's no net force. If it's moving at a constant speed, there's no net force. Okay, so when you're driving down the road at 55 miles an hour, okay, your car is putting out force for sure. Okay, the trick here is net force. Okay, so if you're going 55 miles an hour and you're not changing speed, you're going 55 and staying 55, what that means is the forces on that car trying to slow it down are equaling the forces that you're putting in with the engine. So you're putting in enough force to drive 55, but there's enough air resistance and friction in the tires and other things that are causing that car to push back on it. Okay, so really, as long as we have no acceleration, okay, there's going to be no net force. Okay, this is also called the law of inertia. Okay, and the inertia basically is this tendency of an object to resist change in motion. So we have this principle in our world called inertia. Okay, so if you're an object that has mass, okay, your natural tendency in our universe is to not change. Okay, that's pretty normal for us. In terms of us, most people don't like change that much anyway, but that's actually part of inertia. So if you get something rolling, it wants to keep rolling. If you have something standing still, it wants to stay standing still. Okay, the way that we cause a change is we need to put some sort of net force on that object in one direction to create an acceleration. Now, inertia is proportional to your mass. Okay, so the more mass you have, the more inertia you have. Okay, think about it. It's easier to get, like a tennis ball to throw that across a room than it would be to throw a bowling ball across a room, because tennis balls have less mass, so they have less inertia, whereas bowling balls have more mass, so they have more inertia. So it takes more force to get them to move, to shift, those kind of things. Okay. Being with greater inertia, that also means you are more difficult to accelerate, okay? Which means more massive objects take more force to accelerate them, okay? So think about cars, okay? If you have a little Honda Civic and it has this tiny little engine in it, that tiny little engine with not much power can accelerate that Honda Civic pretty quickly. Those are quick little cars, okay? However, you take a semi-truck loaded down with goods for our country, driving across the country, that semi-truck is extremely massive, okay? Very, very, very heavy, lots of mass there. Even with that gigantic engine inside that truck, those trucks accelerate really slowly. And you know that if you ever got caught behind one at a stoplight, okay? So it's much more difficult to accelerate a massive object than it is a light object, okay? So that's Newton's first law, okay? Is this idea of things stay at rest, or things keep motion unless you act on a net force on those things.